Welcome, everyone. I'm happy to be here. My name is Denis. I am head of AI platform at Tabby Engineering. Evgenii is our engineering manager. And today we will be talking about AI in Tabby, about adoption of AI in company, about real agents working, and how it should be done, how we solve our problems, and so on. So let's get to it. Maybe we'll be having sessions of questions after that, or maybe not, because we are out of time. So let's see how it goes. So, if we are talking about adoption of AI company, why do companies do that? Actually, they can achieve three things. First one is optimizations of operation. Some repetitive work which can be done more efficiently, and its reduction of costs and so on. It's a very important one. Second thing companies can adopt AI for is software development. So we can develop our features, products, and so on much quicker with AI. And third of all is AI products on its own. It's a new features based on AI, having some new products and new improvements of your product, AI itself. Nowadays, this approach also transforming. We are going from AI assistants to AI agents. AI assistants means you have conversation with AI, you are checking with your chatbot, copy-pasting your questions and answers, and so on. And agentic approach is far more efficient when your agents work autonomously on the tasks, and it delivers needed value much faster. It's a several times more efficient approach, but actually it has its own problems. When adopting AI in a company, you will face a lot of issues. First of all, you will need to think about infrastructure, about security, PII data, and compliance. And a lot of things can endanger you. Also, with these agentic transformations we are facing last months even, a lot of people can start to adopt AI on their own. And if you won't handle this, you'll find yourself in a model zoo when a lot of people use a lot of models, creating a lot of agents, and if it won't be centralized and managed, you can face a lot of work after that. It can be catastrophic for you, and it can be very dangerous. Going AI, full AI, isn't so hard, but to do it properly, secure, compliant, is a hard task. At Tabby, and I will be talking most about our UAE approaches. We are still in the process of testing it for KSA. We don't have access to production data from our AI things in KSA, but we have a lot of experience with this in UAE, and we'll be transferring it in a time with KSA when we figure something out. We have AI for several things in UAE. For customer support agents and some operations we have added. We use it to develop our internal products. Let's talk about this actually. Our approach to this potential chaotic things going on with AI is to have our internal infrastructure, internal platform, and unified approach of building AI agents, LLM calls, and so on, because the AI platform. It consists of several things, which of was is very important. And first of all is our AI agent. Not this one. First of all is our AI agent builder. It's unified tool, totally internal, running from internal models, which helps people to build their AI agent, to ship it, to test it, and also to create tools with which our AI agents will be working. An example of usage of this AI agent builder is our CX agent, also running fully on our internal infrastructure agent, which have access to some of the tools our customer support have access, which can in React loop think about questions, get some data, formulate answer, suggest this answer to customer support, and even suggest actions to customer support. And the thing is evolution of this agent. We had a more simple approach from the beginning when we just try to answer like several questions with this agent. But agentic transformation is a lot of transformation of capabilities of our agent, and we introduce skills to it, allowing an agent to answer for different topics, to act like different specialists depending on the task. And also, important thing is development of tools. From the beginning, we had only read-only tools, but now we can even suggest actions to some customer support. But important thing, and it's very important when you are creating some agent, especially some central agent that's such important as customer support agent, is that you need to know that AI agent doesn't and can't possess a responsibility. Responsibility is always on humans. So if you allow your agent to formulate an answer, you also need to have humans who can review it, and it depends, of course, on tasks. But with this agentic transformation, it's one of the most important things. It doesn't take responsibility from you and from humans. And talking about responsibility and the thing to make this agent work properly is our approach to evaluation. By introducing a platform to different operation teams, to different tasks, we also teach and force people to evaluate this agent. By evaluation, I mean running in on thousands of examples and to check that it works properly. And it is a very important task. A lot of people underestimate its complexity and importance, because without evaluation you can't guarantee the thing will work properly or in the production. And also I think worth mentioning, for an engineering approach, we established knowledge base. It's a fully internal thing. Doesn't have access to production, but have an access and knowledge of how our products work, and it can help to answer our agents for several type of things: how to develop something, how to analyze something, and it's a central thing for our next approach, how we will evaluate our engineering. The thing worth also mentioning is we can establish a platform. We can teach anyone to build agents, but it won't work nothing without working it on for us for internal infrastructure on one perimeter, and we build guardrails in our platform. And the important thing is this internal infrastructure. Without it, our agents can't work properly. And I'll transfer the mic to Evgenii. He'll talk more about infrastructure.
Hello, let's check the microphone. This is okay. Uh, so, so my name is Evgenii Perepelkin, and I'm an engineering manager at Tabby, and I'm responsible for the AI infrastructure. Um, and so over the past year, we built our own GPU fleet. And so here our journey traces you made mistakes and infrastructure with the infrastructure which you try today. And so and just Denis showed you what we are building. And so let me show you how you try. And it all started with the six agent which Denis just described. It was our first task. And so we had the C preparation, which framework, which model, and which hardware do we need to use to run. And so we tested a lot, different models, different hardware, different frameworks. And then we just this what we started. The first I was modeled was DeepSeek R1, and we ran it on BH 200. And so for the inference framework, we chose vLLM because it's nothing came close to us. So the best throughput, latency, and stability. So we started simple: one server, one model, and one framework. Oops. So, and this is look what it looks. So on the right side, it create a right to the data center. On the left side, you can see it stored our server in the lab. And it looks simple on the photo, but it's bits of shipping, hardware, and setup. So more and more tasks needed AI at our company. And so we decided to grow our fleet. And so after it, so we decided to buy new generations of NVIDIA GPU servers. It's B200 and V300. And so we bought them for a few data centers based in Saudi Arabia and UAE. And so we have similar infrastructure in both regions. Um, so, and AI world was having boom, and DeepSeek 3.2 was a great start, but better models kept coming. And so we decided to try others models. And we found that when 3.5, 397 billion parameters is better for us because it's bigger and for tasks where it needs to reason. So it has better quality. And after it, Google released Gamma 4 with 31 billion parameters. And so this model is much smaller and faster. And so we use it for tasks where speed matters. So today, we have two production models. It's Red 3.5 and Gamma 4. And it's another part of a story. It's quantization because it changed the economics. Before, like 1 or 2 years ago, you could fit large model on AI GPUs, but now with quantizations, we can use it. We can run, for example, 8 models on 8 GPUs. As you can see with B200 and B300 servers and quantization from NVIDIA, we can run 8 models. And also, for example, with Gamma, we can run a lot of different models just on only one GPU. So here we can see how we can deploy that. So some of us might expect Kubernetes here, but we decided not to use it because it's additional layer, and bare metal gives the path short like line, service, router, framework, and machine. So for orchestration, use Ansible, service, managed build code, and also use a small Python library because it helps to deploy faster, and so it's around 80% faster. But I'm not talking about downloading and frameworks or dropping just for install. But maybe in the future we will use Kubernetes because maybe our feed will be growing. So how do we manage traffic at Tabby? So we decided to build our own router because you have different tasks and different agents and clients. And so, okay, existing solutions, they don't know our traffic patterns, and it allows us to find the best server, and GPUs never sit idle. So the router does four things. So the first one is model selection. So the router is the model for every single call, and if one is down or slow, the router is all based on the chain. So with this we have low latency and SLA. So also the second is sticky sessions. And so because the same conversation always stays on the same provider and regions, because if you switch in conversation, you can lose your context. So sticky sessions prevent that. So the third is limits per team and agents. When you're having a big fleet and different models, different tasks, you need to understand traffic. And so, for example, one noisy team can take all the resources, and so you have specific rules for teams and agents. And we are a little picky about real-time services because they have to do the first. And so legacy sensing traffic is isolated from background tasks. So we benchmark a lot in Tabby because it helps us to understand and to choose the best model, the best framework, and the best hardware. And before you try to use like a synthetic benchmarks, but they lie. And so we decided to copy production use cases because they only real production use cases had helped us to understand real problem, and so we can understand how to adjust our settings configuration files. And also we use like a golden data sets for accuracy. And so here let's see one of the most important metrics for given tasks. For example, in this real-time ADI task, we measure time to first circle. And if it's baseline task, you measure load time and throughput. But for all tasks, we measure accuracy with our golden data sets. So, and as you see here, we will change one thing and your result changes. So it means that you need to measure on real workloads. And also, we tune our framework, vLLM itself, with the benchmarks. And so the default configuration files and metrics are never optimal. And so what we are actually learn. So compliance is our exact goal. So because our models it's offline models. We don't have storage, and also we have to reuse all them. Also, agents in the subtle foundations like models, hardware deployment, and quantization made suppose it affordable. So for example, what server can build 8 models and router because every task gets what it needs and the GPU never sits idle. So things is done. So thank you that you got me. Said that's nice. Thank you.
Thanks, Evgeny. And just to summarize, everything matters and nothing works if you won't handle any of that. So you need an internal prod to be compliant and fully secure. You need right road, and you need infrastructure which is compliant and capable of building good evaluated agents. You need all of that to be able to integrate AI agents and AI fully in your company.